I also want to give you one example of residence times using the method of particle tracking. So you have an area, and this is one example. This is the Mururoa Lagoon, which has been used for nuclear testing in the past. Look it up on the internet. Look it up. Try to find where is it and which ocean. Okay. So this is a lagoon, and you want to know how long does it take for a water parcel to leave this area, to exit this area. And the main exit point is a narrow channel. So this is the configuration, a top view of the lagoon. Okay, and we're talking about the scale is something like 30 kilometers horizontally. Okay, maybe 15 kilometers, 15 to 30 kilometers. And there's a channel connection. This is the main connection to the Indian Ocean. Overall, the lagoon is shallow. Okay? So the deepest points are something like 50 meters or so. Okay, but it also has some minor connections which are called OA, where there is a connection during the high tide. There's water flowing out narrow channels. Okay, there's a connection here. So now you need to work that out. What is the residence time? How long does it take for a particle, for a water particle? Okay, so you develop a numerical model, and this is now shown on the next slide, and you work out the dominant, we call them streamlines, lines along which particles flow, or water parcels flow. And this is what you get here from this. Okay, you get streamlines. So the water move around. Okay? They move around in a generally clockwise sense. Okay, look. And you have a more diffusive exchange across the entrance, and that more depends on the tides. You have it with the outflow, with the high tide, you can escape the channel here in this area. But particles are essentially trapped inside the lagoon for a relatively long time, because you have that limited connection. You only have a narrow channel. Okay, and only if you're really lucky, you might actually escape this area. Anyway, okay, let's have a look at the residence time distribution now, and this is now color-coded. You release particles and you count the time it takes to leave the lagoon, and you can see that on the eastern side here you have an area where it takes more than 120 days, which means 3 months, to leave the lagoon, as opposed to less than 50 days if you're here more closer to the entrance in the western side. So this is all reflected by the circulation, because if you release a particle here on the eastern side, it does not move over to the exit. It just slowly moves around and actually runs along the entire loop until it actually can come close to the exit. And this is what we call residence time, and this is what's used for pollutant oil spill management. Okay. All right. Also for industrial development, indeed. Okay.